moment. So those three areas I think I mentioned earlier were the design and engineering management. So that's the phase we're in at the moment, which is a very early stage. The construction, so taking those models out to site, and then at the end, the facilities management, operation and maintenance, right the way through to the disposal of the asset. Okay, so here's some of the benefits that we get in the design and engineering phase. This has been used for quite a long time. Most of the design companies have been using BIM for probably the last 5 to 10 years, probably 20 years in the petrochem industry. So during this phase of the project, this is the key benefits of what we're using it for. So it's coordination. So all of the stakeholders, like survey, construction, MEP, architecture, all can contribute 3D models to a single federated model. At the moment on this job, they do that on a weekly basis. So we then hold design reviews, clash detection reviews, so everybody can see exactly what everybody else is doing in the 3D environment. Grant will take us through some of those 3D models later on in the evening. Clash mitigation, so when we have all those models together from all those different stakeholders, we can actually do a comparison against them and we can see which say like a HVAC is going through the middle of a structural column. Some of these clash checks can get fairly large. I think the first one we ran at 600 or something clashes to resolve. One of the new areas that we're looking at is actually linking these models to 3D costing information, so databases for that, so that as we make changes to the 3D model, it actually reflects in the price of the thing. So you can do optioneering. You can see, okay, if we move this wall out here and we do this, increase the station by this much, this is what effect it will have on the cost. The use of VR, Grant will be talking a little bit more about that for training. Parkville Station, that's not far from here, is it? No. Okay. So we're actually fairly near to Melbourne. Okay, during the construction, what we're trying to do is reduce the risk by actually simulating the construction in a virtual environment prior to getting to site, so we can see where there's going to be problems, where there's going to be clashes. So I'm just going to quickly go to a YouTube video because that will explain it much better than I can. Can I go for a couple of minutes, 3 minutes? This will explain.
The ability to plan, manage, and track projects in an integrated space-time visual environment provides benefits to all types of construction projects. Synchro's digital and interoperable platform enables improvements across all aspects of the delivery process, from safety, workspace utilization, productivity, quality and reliability, project cost and competitiveness.
Construction projects tend to be projects with a lot of moving parts, labor, material, scheduling constraints. If you don't plan all of those issues out ahead of time, then you're doomed for failure on the field.
Synchro gives the guys who are going to do the work a solid understanding of what the schedule means. Bring in the experts in the field, they tell us their challenges, we make changes, show them options, and they confirm, yes, this is what we plan to do.
We're able to catch things sooner that we wouldn't have caught, and we're also able to explain to the client who sometimes has trouble visualizing in 2D but can clearly see what's happening in 3D, why certain issues are safety concerns, why there are certain logistics, and why certain things can be done and can't be done.
Execution of 4D through Synchro will help a project keep pace with the changes and thus will avert extensive rework, will improve the schedule as the job is progressing, and will certainly lead to a higher quality and higher level of safety.
We use Synchro as a planning tool to identify safety issues and then actually flag those issues inside the model.
Visualization, simulation provided so much better communication about safety and risk. The team went from 10 dropped objects to none, 3 recordable injuries to none, and 1 near miss to none.
Synchro BIM 4D allows us on a monthly basis to update our client in all 3 areas. Our delivery team, Suffolk, loves it. Synchro allows us to run our projects better, that allows us to make our subcontractors smarter. And it's impressive for our clients. So our team embraces it and loves it and wants to do as much of it as possible.
The ability to see, to edit and to optimize every moment of time, minute by minute and day by day, in both space and time, builds the participation and understanding necessary for successful project performance. From tendering through construction, commissioning and handover, Synchro Pro helps the entire supply chain perform better every day of every project. Imagine your project in a time machine, purpose-built for construction demands of the 21st century.
Okay, so I think they explained it a lot better than I could have done. So other stuff that we're using during construction is the use of point cloud scans. So everything that gets built, the construction team go out and do a point cloud scan of that. We then feed that back into the model, and then you can actually see what's been confirmed that, say, piles, for instance, have been put in within those construction tolerances, so that we don't have to adjust the design. To track actual progress against planned progress, so it's also like a tracking tool to see if we're on track. And also during construction, we're also trying to get the use of tablet devices. So rather than delivering drawings to the site, and actually in a lot of cases drawings are out of date, we actually have a tablet device. You can actually scan a QR code on it and see that that is the latest version of that drawing. And you can also walk through the model actually while you're on site. Okay, another picture of CBD South, Town Hall Concourse area. Okay, this is probably one of the growth areas in Australia at the moment that hasn't been explored too much in the past. So the reason for that, why this operation and maintenance phase is so important, is that studies have shown that 80% of the cost of an asset is in the operation and maintenance, and only 20% of that cost is actually incurred while you're designing and building the project. So what we'll be doing on this job is we'll be creating a digital asset. So it'll be a 3D model that feeds into a database. So every item on that 3D model will be tagged. It will link up to a database, and then that will then in turn be read by facilities management software, so they can maintain the project over the next 20 years. That digital asset contains information about materials, quantities, serial numbers of equipment, environmental attributes, replacement schedules, etc. The digital asset can be also utilised for future upgrades. So if people want to go in and do an extension to, say in this case, a railway station, they have all that information that has been verified through the use of point scans. Okay, quick summary. So this is where BIM and virtual design and construction reduces risk. We operate in a single source of truth. So all of the stakeholders, the architects, everything, they all feed into one single model, and all the drawings that come from that are actually all linked to that model. So the only way that you can change your drawing is actually by changing the model. So that same model we actually do clash detection and sequencing on. So once we clash check that model, we know that everything on the drawings has been clash checked and nothing will clash. We then go further and we feed that model to the survey information rather than send it out by drawings. So because we've done that, we know all the drawings on the model have been clash checked and everything. We have that extra surety that everything will fit when we get to site. And then also all the as-built information. So we've got those point cloud scans that are being fed back into that model, so the design team can actually see where a pile's been placed out of interest, and then they can readjust their design. Okay, that's the end of my bit. So does anybody have any questions? Okay, in that case I'll pass you on to my colleague, Ron Smith. Alright, so
to any businesses. Just before I get started on this, any of you guys that are working at the moment, are you using 3D models? Anybody? Are you using the BIM structure at all? Not really?
It's neat text.
Okay, so what about VR setups or AR? Anybody involved in that at work either? No, okay, so this is all fairly new news to you, is that right? You haven't seen this before? All right, so follow on from Stefan, is part of our digital engineering thing is to use VR. We're getting a lot of inquiries about how it can be used in the industry to save time and money. So we always do that. I won't have to because Stefan's already run through that one. And what we're using the VR for is for everybody on the project, not just construction, not just the engineers, not just the architects, but all the project controllers, the document controllers, the executive assistants can all come through and see what they're building. Most people don't know or can't understand from a drawing what they're actually building. So that's why we build models and then we take them through the VR. Unfortunately, we can't take you through tonight. We don't have enough time or space. But we were talking to Stuart before, we can probably set up a VR session through some of the stations for you at a later date in smaller groups or something like that. So if you're interested, talk to Stuart. So we use it for project awareness. We use it for emergency service scenarios, and we're going to be using it for accredited training. Melbourne Metro has a Metro hub that's set down in the Holmes Glen, Tafe Dam, St Kilda Road. And down there we're going to have 4 VR stations set up. And what we're going to do is also engage VR specialists to make the VR models that we're producing a bit more real and a bit more live. So the first part of it, the project awareness, as I said before, we're just running people through it, all the stakeholders, all the workers. We're going to be engaging some of the public for different scenarios as we go through it. Emergency service scenarios, we're going to take the emergency services through the model in a way that they can figure out how to get out of the tunnel or how to get out of the station, the concourse, whichever level the quickest, all their stretchers and so on fit through the doorways, and that'll all be done in the environment. So when we get to the training, the VR specialists plus Holmes Glen will be setting up accreditation training in modules. The first one will be tunnel construction. Another training module will be a shotcrete application. And remembering this will be done in VR. So they're going to simulate what you can see here, this guy spraying the wall. If his shotcreting is not thick enough in certain areas, a red highlight will highlight that area, or sorry, a red circle or something will highlight that area, and it'll be fed back to the trainer, and the trainer can tell this guy to go back and redo that area. So he'll be monitored, he'll be judged, and he'll be ticked off whether he passes or not until he gets this right. Now obviously there's weight involved with these pieces of equipment. So we've been talking to the VR guys, they can add something to the controller which gives it weight. So if that's a 5 kilo or maybe a 10 kilo piece of equipment, they'll get at least a feel for it. They won't get the thrust, but you'll get the feel for a bit of weight in your hand while you're doing this application. We're also going to be getting TBM awareness. All the TBMs around the world are slightly different. So when we get the model from the supplier, I can't remember who the supplier is. No. When we get that model, it'll look like something like this as you see in front of you. And as part of the training, we'll be running people through in the office in VR and nominating all these different locations for different parts of the TBM. So instead of spending 6 weeks when the TBM arrives, walking over, getting familiar with it. When the real TBM gets here, they'll already know where most things are. There might be some subtle differences depending on any changes from the model we receive to the time that the TBM is. But we've saved 6 weeks of on-site training at a huge cost, and there might be, say, 2 weeks left on site to finish off the familiarisation. So the main aim of all this training, as I said, is the familiarisation, but we could reduce costs and time on site, because they're the big ones. We're going to get more inductions done through the site, not just with what you're seeing here. So we get more people more often, so when pieces of equipment are on site delivered, people can just walk onto them without worrying about induction. We've had some metrics done on a previous job, and they were able to bring that 6 weeks training on site down to 2 weeks and get on with the job much quicker. So some other aspects we're going to be looking at through VR. We're going to be doing some fall prevention using dynamic virtual fences. We're going to be running scenarios for establishing site safety, and a lot of telemetry will go with that through the VR specialists so that everything is recorded. So if there is something that goes wrong later on the project, we can always go back and make sure the correct training was done for that individual so that it's covered and nothing gets missed. As Stephen showed, we're going to do some sequencing in conjunction with the VR. How we're going to do that, we're not quite sure yet, but we're going to try and get that in there. We've got clash reviews. So some of the clash that Stephen mentioned, I'll run through I won't get out of this just yet. I'll show you the models at the end of this presentation. And of course, confirming the design intent. We had some architects come up the other day, they were worried about a tunnel and how it felt and how it looked in 3D model and on drawings. So we put them in the VR and it satisfied them that the head height was correct. They got that full spatial awareness from it, and so they could move on with their design rather than worrying about it too much. So what you see here is just a quick snapshot of what you get out of, say, a Navisworks model when you're looking at a clash check. So in this one we've picked, looks like a bit of mechanical model against a structural model. We've run the clash check and there's a few in there, and this is what the representation is there in the green and the red. So we can do two things, well, we can do a lot of things, but a couple of things we can do is then fix the model so that we remove this clash, or we can use this model as well as the VR and go in and have a look at everything in closer format and make a decision on what we're going to do before we actually play with the model and run through again. So we'll probably get ahead of that game. Right, so once you're in the VR space, you can walk through the whole station. It's not just a 10-metre section of it, it's the whole station and as close to what it will look like at the end as possible. Some of the models that you'll see in snapshots of in a minute are missing certain information because of the state of the project. So a lot of the renders, the textures, the colours aren't in these models yet. So we've got the spatial awareness I already mentioned, we've got the modelling and wayfinding. And the last one we had a request for last week is there's a contract in place to build the station, or sections of it, full size. So we're talking a tunnel which is 15 metres high, 20 metres wide, and all they can build in their cost is a 10-metre long piece of it. So from that, we're supposed to get the whole feel of the station. And it's impossible to get the whole feel of the station. And you can only do it for one station or two stations. We've got 5 and they're all very different. So with the VR, you can get in there, see how every station looks and feels. Apparently for the Flinders Street station ticketing area, they built that full size at a mock-up out in the sticks somewhere, because they had to find somewhere to build it as well. And then they ran people through it, timing, how long it would take them to get to their platform, get a ticket, go through the gates, and we're going to try and replace that with VR setups as well. So there's a big cost saving in trying to find somewhere to build these things. Right, so with the VR modelling, you can see it's not bad. It's fairly accurate. Once again, a few colours and things like that need to be tweaked. But this is the Parkville station at platform level. This is the town hall station, the event space. You saw an earlier Wayne Steffens model with a bit fancier rendering on it. This is the town hall station at platform level. And this is what will be the new North Melbourne station, which is in Arden Street. Before I open up a couple of models, you can go to this website to find out more about the Melbourne Tunnel project. There's also links there for job applications. Anything you can find, any information out will be at this website. There's a Metro Tunnel headquarters at 125, 133 Swanson Street, and you can go in there and they'll also give you a bit of a run through the project. It's pretty hard to see what that is. What we have here is the Domain station, which is the Anzac station. And you can see there's a lot more to it than just a platform and a concourse. So when we look down through here, and this is the early stages, so this is just basic outlines of piping and ducting. In a year's time, you won't be able to see anything below all the piping and ducting once everything is in place. So these are the kind of things we look for when we run a clash detection. You can see there, these sort of things will be highlighted. You've got pipes running through ducts, and so on, all through every station. So here you can see the difference between this one. There's a lot of colours showing things. It's a lot of grey for concrete, blue for ductwork, thick for piping, or whatever it happens to be. So it doesn't look all that real. So when we take that same model and put it into the VR space, you get a bit more reality going on here. So, of course, you're not going to see all that piping and so on through it because it's all in the back of the house. What you're seeing here is the actual finished product that you'll actually be walking into. Once again, I know we're looking at a 3D model on the screen so that you don't get the same kind of feel as if you're in the VR space. You can come down, right down to the platform. So you see some of the architectural features, lights, etc. already placed in there. We've got security screens along the platform edge, so no one can fall off the platform. And as we go through the project, the textures, colours, everything will be refined, so that when we do this, the final product will be out there for people to go through. that's about here.
Is there any questions for Stefan or Grant?
Sure.